set kayo ng assumption, di ba, initially, which is hindi naman natin sigurado kung tama yung assumption. So, pero pwede na naman natin gawin. Pero pwede rin kasi magbago ng direction with respect to the actual computed value or yung direction niya. Okay, sige. Okay. Dito tayo nagtagal ng last time. Ipapaliwanag ko na rin. So, we have three sources. Meron tayong voltage sources, yung battery A and battery B. And then, a current source, 0.5 ampere. So, initially, yung ating step-by-step procedure are ito. So, first, assume initial branch current direction as reference. Then, number two, consider the effect of each source at a time. So, one source per time lang tayo. Then, neglect the other effect ng different sources. Okay, so in this case, the following independent voltage sources will be shorted. Then, the current sources will be open. So, yun yung magiging equivalent effect of other sources. Then, analyze the circuit and compute the branch current. Then, get the jailbreak sound. Okay, so for the first step, nag-assume tayo ng current direction. The next step is to consider the effect of the source or voltage source A sub A. So, therefore, the two remaining other sources, especially the voltage source, will be shorted. And then the internal resistance of the battery will be the circuit connection. And then, while in current direction, so 0.5 ampere. So we have 0.5 ampere current source, so it will be open. So this will be the output nakuha ating effect of the battery A. So next step is to find current flowing to each resistor. Pero ulitin ko ha, depende sa problem kasi yung hinahanap. In this case kasi compute the power across each resistor, meaning we need to compute for the current on each resistor, R1 and R2. Pero in case na in the given problem, nahanap lang yung power across R1, so hindi na natin kailangan i-identify or i-compute yung value ng current flowing to R2. So yung tawag dito, yung hinihinging value lang. Naintindihan? So hindi na kailangan i-compute yung iba pang branch current kung hindi naman kailangan or hinihingi sa problem. Okay. So, balik na tayo dito. Okay, initially, we're going to find the current flowing at R1 and R2. So, since we are considering E sub A as the first source, so iset natin yung mga current values and even the other values such as resistances, total resistances, and total current as prime values. Wait lang. Hindi pa rin na-edit ko. Na-edit ko na. Wait ha, double check ko lang. Bakit yung bago? Binago ko na yun. Wait. Hindi ko na nabago yung PDF file. Sige. I-double check ko na lang ulit mamaya. Yung PDF file hindi nagbago. Ay, hindi ko na i-overwrite. Wait lang. Yun yung naman yung naging bago. Okay. So, sino tayo? So, for the total resistance prime. Kuha. So, in this case, ito yung ating connection. Then, we get the total resistance is equivalent to the summation of the resistances connected across this. Kumbaga, meron na lang tayong single loop. Naintindihan? Yung naging output circuit natin. So, we have 151 equivalent resistance. Then, therefore, we get the current going at R1 and R2. So, since our, we have an equivalent series circuit, so the current flowing at R1 and R2 are the same. Then, take note, we have to this the current flowing direct or the current direction on each resistor. So, based from the polarity of the battery, so by following the conventional current flow, so ito yung ating current direction. Meaning the current flowing at R1, so ito yung mga directions natin, R1 and R2. So they are the current I1 prime and I2 prime. And then to get I1 and I2, so since we have a series circuit, so yung current flowing at R1 and R2 are the same, which is equivalent to 1.326. Okay, so considering the second source, yung 120 volts, ito. Nakikita ba? Okay. Nakikita? So, we have the second source. So, in this case, again, we have to short the equivalent or neglect the effect of other sources. So, yung E sub A will be shorted and then the 0.5 current source will be open. And then, again, the equivalent circuit with respect to the effect of battery B would be ito, yung ating circuit diagram. Nakuha. So, still we have an equivalent series circuit. Pero ulitin ko ha, depende sa connection, type of connection ng circuit, yung magiging output. Kasi ito, we have 3 supplies or sources with 2 windows. Pero for 3 or more windows, so syempre mag-iiba yung equivalent equivalent circuit diagram with respect to the effect of each supply. Okay, so let's proceed. Getting the total resistance first. Nakuha. So ulitin ko, hindi kayo pwedeng magkamali ng current direction with respect to the effect of a single source. Naintindihan? If you're going to use conventional current flow, i-apply nyo sa lahat ng circuit. Kung gagamit kayo ng electron flow, i-apply nyo rin sa lahat ng solution or process. Nakuha? So, hindi pwede magbaligtad yung polarity ng battery. Kasi kung dyan kayo mag-base ng current direction, magkakaroon na kayo ng problema. Okay, for the second supply, so we have an equivalent of resistance, 151 ohm pa rin. Kasi since same connection lang, yung output, then, okay, let's proceed to the current direction, current value. Actually, yung current, kung papansin nyo, nag-iba. Bakit nag-iba? So, saan tayo magkaroon ng difference? So, with respect to the supply, so yung value of the source B is different to the source A. Diba? So, I total double prime for the second supply. So, double prime na tayo. Then, we get 0.795 ampere or 795 milliampere. Then, by inspection, again. So, yung ating I1 and I2, double prime, uh, has or have the same current value. Pero yung direction is opposite to the effect of source A kasi magkaiba sila ng polarity. Buhat. Then considering the source of current source, 0.5 ampere. So take note, in current source, meron tayong current direction. Ito, with respect to the arrow. So you have to check the direction of the arrow kung pataas or pababa, depende sa connection. Naintindihan? So yung current source niya is going upward. So meaning, it will be divided this direction. So yung R1 and R2, kung mapapansin nyo, same position na sila. Then the effect of battery E sub A and E sub B are shorted. Okay, in this case, since we have the current source, so we can apply current divider for two parallel resistances or branch circuit. Actually, branches lang. Two branches lang. Okay? So, yung current divider, napiliwanag ko na ulit. Di ba? So, we have 0.1662 ampere and 0.334 ampere for I2 triple prime. And for I sub 1 triple prime, you have 0.16622 ampere. Okay, next step. Since we have the following current value with the equivalent current direction with respect to 0.5 ampere current source, so we can now get the equivalent sum of the components for resistor R1 and R2. So to get the sum or algebraic sum, okay, for R sub 1, check nyo yung direction. So initially, nag-set tayo ng direction leftward for I sub 1. So all current components with the same value or with the same direction will be set as positive. Nakuha? And then, R1 kasi natin is leftward, di ba? With respect to E sub A, current direction leftward. So, therefore, it will be in positive polarity. In I sub 2, set tayo na upward.
Si Suseng, binigyan mo na?
Yung direction for R, mapapansin nyo is opposite to the initial direction. So, meaning, we can set
Sel, pabigay kay ano, Sel?
current flowing I2 prime
Ayaw
as
ko na
negative.
bibigay.
Ay, good morning po, little sweet.
9. So,
Oh.
yun yung gagawin natin.
Magkano
Pairing
po?
the difference of the
1,000.
respective the
Isang ulam lang yun.
Okay.
Kapang kanin.
each source. So, ito yung mangyayari. For I sub 1, we have positive for the same direction, negative and negative for double prime and triple prime. Okay, so ito yung magiging sagot natin. Okay, take note, we have a positive value, meaning, ano nangyari? Yung ating assumption or assumed direction is the same with the actual direction. Pero kung makakuha mo kayo ng negative value, so yung assumption or yung assumed direction natin is only opposite to the actual direction. Kaya nga sabi ko kanina, hindi na gaanong importante yung pag-assume ng current direction kasi you can just get the algebraic sum, then mag-set kayo ng polarity for a certain direction, and then for the equivalent opposite direction, we'll set a negative value. Naintindihan? Okay, for I sub 2 or I2 prime. Kumbaga, sa mechanics, hindi ba? Pagka sinabing components, so isang may certain ano bang tawag ka? It is only a part. Tama? Hindi siya yung as a whole. So, para ma-compute nyo yung whole magnitude, in this case, kailangan nyo kunin yung summation of the components. So, yung I2 natin is negative, I2 prime. Bakit? Nag-set tayo ng upward direction initially. And for I2 prime, we have a downward direction with respect to the effect of E sub A. So, magiging negative. Then for I2 double prime, upward, so we set positive. For I2 triple prime, downward. Yung current flowing at the resistor R2. Therefore, it will be set as negative. Okay. Ito kung makapansin nyo. Ano nangyari? Di ba naging negative yung total? So, kunin lang natin yung absolute value to get the magnitude of the current. Actually, ang kailangan natin is the magnitude of the current. Itong negative value lang is used for the direction ng current. So, meaning, initially, nag-set tayo ng upward direction kasi by applying KCL, di ba? Summation of current entering a junction or a node is equal to the current leaving. So, based from the initial assumption, papansin nyo, E sub A going to this or is directly towards the junction. Ito, yun nasa upper junction natin. And then, nag-set din tayo ng E sub B entering the same junction. Then, for 0.5 ampere current source, so lahat sila nag-enter. So, in actual, dapat at least may isang branch na mag-giveaway for the other current. Naintindihan? So, dapat may magbaligtad dito sa dalawa. Itong current source, hindi na to pwedeng mag-baligtad direction. Usually, ang nagkakaroon na tayo ng different direction kasi nag-assume lang tayo rito yung current direction. Nakuha. So, either sa branch I1 or branch I2 yung magkaroon ng opposite direction. So, in this case, yung I2 yung so, mababa yung effect. The other for yung current will circulate. Ito, with respect to 0.5 ampere current source, yung circulation ng current niya is counterclockwise. While for the effect of E sub A, so yung mag-circulate yung current kasi clockwise para makabalik at the negative terminal. Naintindihan? Okay. Okay na tayo rito. Wala tayong problema. Then, to get the equivalent power, so we'll just apply the power formula I squared R. Okay na? So, yun na may naging problema natin. Wala nang iba. So, balik tayo rin sa delta Y transformation. Review ulit tayo. Para maging so na yan. Wait lang ha. Come on. Okay. Okay, for delta y transformation, kailangan nyo kamisaduhin ito. Intindihan? Yung delta to y equivalent formula. And then, with y to delta transformation. Okay, dito, nung nakaraan, di ba sabi ko nagkaroon tayo ng problema? Pero, actually, nung double check ko, nagkaroon lang ng typographical error. Okay? So, wait lang. Hello. Okay. So in this case, we are going to use to find the power of loss 220 ohm. So ito yung 220 ohm. Using delta to y transformation, when you see delta to y transformation, we are going to locate a delta connected resistors and we are going to convert it into y. So bakit ba natin kailangan i-convert? Kasi initially, we are going to apply a simple series, parallel, or combination circuit analysis. So, hindi natin pwedeng i-simplify itong given circuit or we cannot solve for the power across the resistor R6 kasi from the first place, we cannot compute for the equivalent total resistance ng given circuit. Naintindihan? So, for example, we are going to assign terminals from this circuit. So, mag-set tayo terminal A. So, in this case, for complex circuit, pwede na tayo mag-set ng different terminals, ha? So, yung ginagamit natin dun sa unang value, kung medyo gabay na kayo, pwede yun nang mag-set ng terminal. Actually, A, B, C, D, pero pwede rin naman i-apply. So, depende pa rin sa inyo. Sige, gamitin natin. Wait lang. A, B, E, C, C, terminal B, E. Okay, so ibig sabihin, may mga terminals na tayo. So, in parallel connected resistors, dapat both end of each resistor or each branch must be connected at the same end terminals. So, kumbaga, if the two end terminals of each resistor R1 and R2 are connected at terminal A, so the other sides or terminals of each resistor must be connected at the same terminal. So, in this case, we have a parallel circuit. Pero kung i-analyze natin ang problem, itong 40 ohm, check natin ha, is it parallel connected to 60 ohm? So yung end terminals ng R2 and R3 are connected at the same terminal which is A. Naintindihan? Pero yung end terminals, bawat branch are connected at different terminals. So yung R2 is connected at terminal B while R3 is connected at terminal D. So really, they are not parallel connected. Same with R2 and R4. Although they are connected at the same terminal B, pero yung kanilang other end terminals are not connected at the same terminal. Intindihan? So, hindi nyo naman pwedeng i-simplify ito. R2, R4, and R6. Okay, so ang gagawin natin, we are going to use the delta to y or either y to delta transformation. Pero, take note, tingnan nyo muna kung ano yung hinahanap na value. Kasi, if we are looking for the power across 220 ohm, so hindi natin pwedeng galawin yung connection of the 220 ohm. Okay. Dito muna tayo sa delta to y transformation. In finding the delta connected resistors, meron na tayong delta connected resistors or connection at this portion. Tama? So, meron tayong first delta connected resistors. Then next, ito delta connected din to. Pero sabi ko nga, since we are looking for the value of 220 ohm, wherein at this connection, located dito yung 220 ohm. So, meaning we cannot use this delta connected resistances. Same with the connection. For example, a connection, kasi ito, we have a resistor, R1, R3, and R5. Are they connected in delta? Tatanungin niyo ako. So, ang sagot is hindi. Kasi initially, in this branch, we have the supply. So if you are going to take the total resistance, you have to remove the effect of the supply. Naintindihan? So hindi na sila magiging delta. Okay. Mahahanap naman tayo ng Y to delta transformation. Ano yung mga Y connected resistors natin? So ito. It is a Y connected. Y connected yan. Pag in-stretch nyo. Nakuha. Pero ang problem is, tinamaan yung R6. So, hindi natin pwedeng i-apply yung Y to delta transformation at this connection. Next is ito. We have the another option. To delta to. Sorry. Y connection din. So, we have a common junction. Connected yung 3 branches at the same junction. Naintindihan? So, ito yung Y connection natin. So, pwede natin itong gamitin. Kasi yung R6, hindi naman siya connected H branch. Okay. Pero din tayo another Y connection. Ito actually. Pwede nyo i-consider to as Y connection. Pero ang problem kasi is tinamaan yung R6. Okay. Kasi initially, kung tatanggalin natin yung effect ng supply, ito yung magiging circuit diagram. So, naka-open yung terminals natin dito. Intindihan? Okay, so let's proceed. Tatagal na tayo. Okay, ito na yung series, sorry. Yung conversion from delta to Y. So, pwede kayong mag-set ng terminal. Sabihin nyo, or you can let, or set terminal A, terminal B, terminal C. So, small letters lang para meron kayong note regarding the connection of the converted resistances. Naintindihan? So, ito mas effective to. Kasi minsan, mayroong, in terms of transformation, nagkakaroon ng confusion. So, yung kasi may mga resistor na nawawala, may mga resistor na dadagdag. Para hindi kayo melto, mag-set kayo ng terminal. Okay, once na i-convert natin yung equivalent resistances from delta to Y, so we are going to substitute the following values to the um, simplified circuit. Okay, wait lang. Pareho lang. Yun yung okay, sige, hindi ko na na-edit. Siguro, bali, ano bang pinagbago? Ito na yung ating magiging new circuit direction, new circuit diagram. Naintindihan? So, yung terminal A, connected sa end ng terminal X. Ito yung A. Yung B is connected at the end of terminal Z. So, yung Z natin ito. Terminal B. Or terminal C. So, at the end of resistor Y. Pwede kayo mag-set ng terminals. Naintindihan? So, papansin nyo, nagkaroon ng changes sa circuit. Di ba? Mas madaling i-analyze. Nagkaroon tayo ng series, parallel, or combination circuit that we can simplify or get its equivalent total resistance. Okay na? So, we have two parallel branch circuit. So, getting the equivalent resistances or resistance of these two parallel branches. So, for the then get the total resistance. So, we have 80 ohms. Okay, since katuhan natin yun. Teka. 220. Okay, hindi ko na na-add. Nakatakot. Wait lang ah. Kasi screen natin nagbago. Dapat gagamitin ko ito sa kabila. Ito. So, papalitan ko ito lang. Dapat ito yung supply natin. So, i-edit ko na lang ulit. Pero check natin. Kasi baka nabura ko yung total current. Total current is 3 ampere. Okay. Tama lang pala yung connection. Pero hindi ko nang naibago. Kasi nagamit ko yung figure at superposition kanina. So 3 ampere to. Kumbaga nagre-redraw lang ako ng bagong circuit diagram. Kumbaga kinuha ko yung current flowing at this branch which is 3 ampere. And we have two parallel branches. So by applying current divider or pwede naman kayong gumamit ng voltage divider, depende sa inyo. To get the current flowing at resistor R6. Ito. Yung total current natin is 3 ampere nakuha. And if we are going to calculate the resistance ng R6, ayun. Kasi at this branch, we have a series branch, 220 and 20, so a total up to 40. So we have current at 80 ohm. So galing current. Di ba, nagkamali lang ako sa hindi to 80. Sige. Ito na yung current at 240 ohms. Naduling na ako. Bale, Same value naman yan. Nagkamali lang ako ng sub, so ulitin ko na lang ulit. Then, okay. Same formula. I squared R. So, we have 79.2 watts. Okay. Okay na tayo dito ha. Medyo ayusin ko na lang yung sum and value. Okay, using Y delta transformation. So, napaliwanag ko na kayo na. We can use the Y connected resistances on this portion. Ito, mag-set tayo ng terminal A, B, and C. So, yung Y connected resistances or resistors will be converted into its equivalent delta connection. So, we apply the formula. So, we have the value of A, B, and C. Then, redraw the circuit and replace the old Y connected resistors to its equivalent delta connected resistors. So, meron na tayong mga values. So, pwede tayong mag-set ng terminal A and C. So, initially, yung R2 and resistance A are connected in parallel. R6 and C are connected in parallel. And then, the combination of the two is connected in series. So, yun yung circuit reduction natin. Okay. Simplifying the circuit. So, ito na yung mga following values. So, we have the total resistance. Same resistance, 80 ohm. Mapapansin nyo, pareho lang yan. Dito. Using the other method. Okay. So, once na nakuha natin yung total resistance, you can use the voltage divider from the simplified circuit. So, ito na yung simplified circuit natin. So, 99 minus 36. Actually, nakakonect siya in parallel. Nakuha. So, it has an equivalent resistance of 60 ohm. So, okay. Applying voltage divider principle. So, getting the voltage drop across this terminal, since yung nahanap natin 220 ohm is connected at this terminal. Okay, you have the formula. Voltage divider, 220 for supply multiplied by 60 divided by to the sum of the series connected resistors of this branch. So, we have an equivalent of 180 volt output. Okay, next step. So, i-extract natin tong 60 ohm. Nakuha? O, i-isolate natin from the original connection. Yung 60 ohm has an equivalent connection of two parallel branches. Merong 108 ohm and 36 series combination of 36 and 99 ohm. Then again, we are going to consider the series branch kasi we are using voltage divider. So, yung 99 ohm, yung i-consider nating voltage output. Bakit? Kasi andito nakakonect yung 220 ohm. Okay? So, by applying voltage divider principle, so we have an initial ulit na ito na yun. Yung 180 volts, di ba? Connected in parallel. Pero since they are in parallel, they have the same voltage. Pero ang concern natin is kung saan nakakonect yung 120 ohm. Therefore, we can neglect the effect na itong 108, then consider this series branch. Kasi ang voltage divider is applicable for series branch while the current divider is for two parallel branches. Okay, so saan tayo? 180. And ayan, meron tayong computed 132 volt. Okay, next step. At this terminal, we have 132 volts, di ba? Ito yun. So, by isolating 99 ohm from its original connection, andito yung R6 and 180 ohm. So, they're connected in parallel, therefore, they have the same voltage output or terminal voltage. So, meaning, we have equivalent voltage for 220 ohm, which is 132 volts. So, we can now apply the power formula to get the output power across 220 ohm, which is 79.2 watts. Okay? So, review lang tayo. Actually, ito yung next topic talaga natin. Nakakasunod. Actually, review lang yun. Ito talaga yung topic natin. So, in Thevenin's theorem, we have the Thevenin's theorem. So, in Thevenin's theorem, ano bang ginagawa? Actually, we have to consider this bilateral network. So, in Thevenin's theorem, we are simplifying the circuit to its what we call the Thevenin's equivalent circuit. So, initially, we have a complex circuit, tama? And then we have or what we call the two-port network. So, we have to convert the initial circuit into what we call the Thevenin's equivalent circuit. So, ano ba nangyayari in Thevenin's equivalent circuit? Initially, we are looking or first step kasi rito is to isolate the load resistance. Yung resistance na hinahanap natin. Naintindihan? Ito yung load resistance. And then, finding the equivalent Thevenin's resistance. So, ito yun. Actually, may formula tayo rito. Wait, ayaw magsagot. So, ito yung Thevenin's resistance. And then, looking, actually, it is also called as the looking back resistance. And then, after calculating the Thevenin's resistance, is to get the equivalent Thevenin's voltage. So, ano ba yung pinagkaiba ng dalawa? So, mamaya ipapakita natin sa example yung process. And then you have to consider this Thevenin's equivalent circuit, di ba? Actually, in Thevenin's equivalent circuit, we have a series circuit wherein the supply is the Thevenin's voltage and the resistances which are connected in series are the Thevenin's resistance and the load resistance. So at load resistance, we have the current flowing at the load, which is the IL or the load current. So in Thevenin's theorem, we are going to identify or compute for the load current with respect to this equivalent circuit. Okay, to compute for the load current, we apply KVL. So it is equivalent to Thevenin's voltage over the sum of the series connected resistances RTH plus RN. Nakuha? So we have the following definition. Hindi mo definition. Okay. Sige, para mas mabilis, i-apply natin sa sample problem. Okay. Nakikita. Okay, so yung sample problem natin, number 1. Determine the current across 5 ohm resistor using Thevenin's theorem. So in Thevenin's theorem, 5 ohm resistor is the load resistance. Ito. Nakuha? So the first step is to isolate the load RL. So when we say isolate, we are going to disconnect. Tatanggalin natin to from the initial circuit. So ano mangyayari dyan? So the new circuit to consider. So ito, may battery. May battery rin tayo. Naka-open yung connection niya. Terminal A and B. So pwede natin ito iset as terminal B. So i-isolate natin. Tatanggalin natin yung load RL. Okay, next step. Isolating the load RL. So, ito na yung naging new circuit to be considered. Okay. So, first step. Either you can compute for the Thevenin's voltage or the Thevenin's resistance. So, in this case, we're going to locate the or to find Thevenin's voltage. So, saan ba natin kukunin yung Thevenin's voltage? Actually, it is the equivalent voltage drop or terminal voltage at the isolated terminal of the RL or load resistance. So, from terminal AB, kunin natin yung equivalent Thevenin's voltage. So, how to compute for Thevenin's voltage? So, you can apply KVL to calculate the Thevenin's voltage. But take note, kasi ang problema natin dito, we have to check the remaining circuit. So initially, if we are going to apply KVL, di ba per loop ating analysis. So pwede tayong kumuha ng KVL at this loop. Pwede rin tayo mag-apply ng KVL at this loop. Naintindihan? But the problem is we have a closed circuit on this portion. Ito yung closed circuit natin, di ba? So in closed circuit, and with the given supply, so there's a circulating current at the loop, at the closed loop. Kasi mapapansin natin, itong portion na to, hindi ba may loop tayo rito? It's considered as open loop kasi yung terminal A and B are not connected. Same with yung kaninang loop na ginamit natin kasi we have to consider the loop. Siyempre, kung saan tatamaan yung unknown terminal natin o yung hinahanap. Kasi pwede tayo mag-KVL dito. Pero hindi natin makukuha yung VTH. Pero it's important to consider this closed loop first. Calculate the circulating current. Kasi kung mapapansin nyo, di ba kung nag-KVL tayo, iset natin ito for example, positive, okay, positive and negative. Di ba? KVL tayo rito. So we have positive Thevenin's voltage. So anong susunod? Then we have the A sub B. So taking the negative polarity of E sub B, we have negative E sub B. So ano next? To get the voltage drop across the 3 ohm resistor. Nakuha? To get the voltage across the 3 ohm resistor, we need the current. So first step, hindi natin ma-i-assign kung either ang direction ba ng current going at 3 ohm is pababa or pataas. Naintindihan? So yun yung unang problema natin. Hindi natin alam kung positive or negative ang polarity across voltage 3 ohm. And then next is the current flowing at 3 ohm. So it's not directly given to the problem. You multiplied by the value of the R3. So actually, yan. Ito yung magiging KVL formula natin or equation. So we have unknown I3. So pinakamadaling gawin, sabi ko nga kanina, is to check the circuit connection. So check a closed loop and then find the current. So in this case, find the current flowing at 3 ohm. Same with the, kasi pwede rin tayo mag-KVL. This loop. Nakuha. Okay? So, tayo sa baba. By solving the circulating current at this closed loop, so we can apply KVL. KVL pa rin. Kasi since given na yung mga supply and the equivalent resistances, so we are going to find the circulating current. Naintindihan? So by applying KVL, so ito yung formula. Actually, in this case kasi sa KVL, di ba? Pwede tayong mag-consider ng tawag ito, direction, loop direction. So mag-set muna tayo ng polarity for the batteries. Positive, negative. So positive, negative. And then for the current direction. Initially, yung current direction dito is assumption lang. Initial as setting. Kailangan nyo mag-assume, di ba? Yung current using KVL. So, nag-assume tayo based from the larger value of E sub A. So, 20 volts versus 10 volts. So, syempre, mas mataas or mas malaki yung pressure from 20 volts. So, nag-assume tayo na yung current will flow with respect to the or with respect to the or in favor of the 20 volt voltage source. So, ginamit natin yung assumption ng current to set polarity for the resistances R1 and R2. Okay, by applying KVL at this loop, get the polarity. Positive E sub A. Next is negative E sub B. O nga, kinukuha natin yung polarity kung saan lumabas yun. And then next is to the voltage drop at the resistances. So initially, comparing to the assumed current direction, since it is in a series circuit, so we have a negative value nakuha or the unknown value of I multiplied by the series negative resistances. Actually, pwede nyo rin isa-isahin. Pwede yun. Kasi pwede. Isa lang naman din yung resistance pero pwede natin isa-isahin. R sub 1 negative I times R sub 2. Then same with the voltage drop across the internal resistances. So they have the same current I. So RB minus IRA equate to 0. Nakuha? So initially, factor out I. So R sub 1 is R sub 2 is R sub B plus R sub A is equivalent to 0. So rearranging the equation, ito yung magsisilbing formula natin to get the circulating current. So we get positive 2 ampere. So meaning the assumed current direction is the same with the actual current direction. Okay? So yun, pwede nyo i-derive yung ating KVL dito. So kung medyo nahihirapan kayo magkabisado, di ba? So lagi nyo hanapin kung ano yung pinag-ulan ng formula. So mas madali kasing maintindihan. Sakaling malimutan yung formula, so you can derive on your own. Okay, so we have a circulating 2 ampere. Dito lang siya. Ulitin ko ha. Current will flow only as a closed circuit. So kung open yung circuit, walang current na dadaloy. Pero you can still measure the voltage. Kaya ito yung Thevenin's voltage. For example, kung gagawa ka ng experiment, kuha kayo ng voltmeter. Di ba open circuit to? Meron pa rin kayo mag-measure ng voltage dito. Pero walang current. Ako ha? Okay, sige. Balik tayo. Okay, so we have the current direction and the current amount flowing at resistor R1 and R2. Now is next step is to apply KVL to get the Thevenin's voltage. Nakakasunod. Hello, hello. Naintindihan yung process natin? Okay, sige. Ang walang tanong. Let's proceed to get the Thevenin's voltage. Okay, in Thevenin's voltage, we are going to use this loop. Naintindihan? So, from this circuit connection, we have now assigned a current direction, which is downward. Kasi pwede yan maging opposite kung larger ang voltage dito sa branch na to. Okay, with a certain value of I, which is 2 ampere, applying KVL. So initially, ano ba dapat polarity nitong PTH ito? So actually, if you're going to follow the conventional flow, ito yung positive, ito yung negative. Bakit? Kasi by following the conventional current flow, the current will leave the positive terminal of the supply going back to the negative terminal. Naintindihan? So meaning, yung direction ng ating current isa kinalan ka as positive. Kung magkamali man kayo, for example, ang assumption is sa direction lang naman din. Hindi naman sa magnitude. Okay? So, start tayo. PTH. Ito na. Actually, nakasulat na. So, isinulat ko na rito. So, we have the Thevenin's voltage, VTH. Then, ito, voltage drop across R2. So, get the negative polarity. So, dito, usually, mag-set na lang kayo na positive para masundan yung solution. Intindihan? So, negative kasi we need to take the polarity where the loop comes out. So, in this case, across the voltage drop across resistor R2, so it leaves the negative terminal. So, we have a negative. Then, at this branch, considering this branch, diba? We can take all the resistances, get the sum to get the equivalent voltage drop. So in this case, we have the series R2 and internal resistance 0.4. So pinagsama na natin. Then next is getting the polarity of the supply, E sub B. So we have a negative value. So E sub B then equate to 0. Rearrange. So since we are looking for the terminal, Thevenin's voltage, so transpose lang natin to the other side kasi positive na to. So i-transpose na lang natin yung remaining term, the other side. So ito yung magiging solution. So we have the computed current times 3 plus 0.4, so 3.4 plus 10 volts. So we have a Thevenin's voltage 16.8 volt. Naintindihan? Kumbaga ito yung voltage at this terminal. Naintindihan? Kumuha kayo ng voltmeter, ito yung makakompute or yung measured value at this terminal. Okay. Another approach to get the Thevenin's voltage. So, considering the other loop, dito naman tayo sa labas. So, anong gagawin natin? So, set the polarity, positive, negative, then get the polarity where the loop comes out. So, positive across resistor R1. So, it leaves the positive terminal with respect to the current flow 1, yung ating polarity rito. Then, we have a negative for the supply E sub A. So, in this case, PTH plus I times R1 plus RA, actually positive ito, minus E sub A is equal to 0. Then rearrange the equation. So, ano mangyayari? We have E sub A minus I times R sub 1 or quantity R1 plus RA. Kuha, substitute the following values, 20 minus 2, quantity 1 plus 0.6 ohm. So, we will get 16.8 volts. So, same answer lang ang makukuha natin at different loop. Nakuha? Okay. We have the Thevenin's voltage. Next is to find the equivalent Thevenin's resistance or the looking back resistance. Okay, in finding the looking back resistance, we have to neglect the effect of the independent sources such as the voltage sources and the current sources. So all voltage sources must be shorted and the current sources Must be open. Naintindihan? When we say shorted, i-close mo lang. Same with the superposition pala, sorry. Same with the superposition theorem. Okay. So, next step is, ito medyo madali lang to. So, you have to compute for the equivalent resistance or the RTH. Dahil may equivalent circuit natin. Then, shorten na yung equivalent. Isa B and isa B. Okay. We have a series connected branch R1, 1.6. So, R2 and RB, we have 3.4. Naintindihan? Therefore, two parallel branches, RTH is 1.088 ohm. So, during examination, pwede kayong kumuha ng at least 2 to 3 decimal places. So, kahit okay lang yun. Kahit 2 to 3 ang kunin yung decimal places. Kasi double check ka naman sa solution. Okay, next step. Consider the Thevenin's equivalent circuit. Okay, since we have the RTH and the VTH, okay, now redraw the circuit. Ito, importante to sa solution. So, kailangan ko makita yung Thevenin's equivalent circuit. So, ano ba yung composition ng Thevenin's equivalent circuit? Actually, it is a series circuit composed of the Thevenin's voltage and the series connected RTH and RL. Actually, yung isolated load RL natin, dito natin ibabalik. Okay. So, we have the VTH, RTH, IL. RL. And then, to compute for the load current, we apply, actually, halos na kVA lang din tayo dito to get the load current. So, VTH over RTH plus RL. Then, divided 16.8 divided by 1.088 plus 5 is 2.76 ampere. Naintindihan? Okay. So, ito yung Thevenin's theorem. So, next step. Next example. Okay. Determine the current across 2 ohm resistor using Thevenin's theorem. So, ito yung ating circuit connection. So, kung mapapansin nyo, we have 3 voltage sources. Naintindihan? And then we have the load resistance RL, 2 ohm. So, first step is to isolate the load RL. So, tatanggalin natin itong RL from the circuit. Okay. So, once na ma-remove natin yung load RL, so, we have to consider the circuit. Siguro, redraw ko na lang muna rito. Kasi may solution na yun. Minsan, medyo nagkakalito. Okay. So, ina-isolate natin. So, we have the terminal A, terminal B. Ako, isab-si tayo ng RC. Isab A, RA, R2, EB, and RB. So, we have the R sub 1. So, in this case, ano yung gagawin natin? We are going to look for the Thevenin's voltage. Same procedure tayo. Tama? We can apply KVL to determine the VTH. So, we can use this loop or outside loop to complete for the PH. Pero ang problem ulit kasi natin dito is ito. Saan dumadalo yung current in the given or from the new circuit diagram. So again, ulitin natin ha. The current will flow at a closed loop only. So meaning, there will be a current flowing at this loop, but on this open loop, wala tayong current na magsisirculate. Intindihan? So therefore, before we apply the KVL to get the VTH, or we need to calculate the current flowing at resistor R2 or either R1, where we can get the value for the Thevenin's voltage. So same procedure lang din kanina. Ano ba pinagkaiba nito? Actually, nag-set lang tayo ng E sub C. Pero ano ba yung magiging effect from the calculation of Thevenin's voltage of this connected E sub C or battery C? Okay, let's proceed. Ha? Okay, compute first for the circulating current I on the resistor. So actually, kino-compute natin tong current kasi when we apply the Thevenin's voltage, kailangan merong current na dumaloy sa R2 dahil meron tayong close circuit dito. Intindihan? Kasi kung hindi nyo i-compute yung current dito, kakaroon tayo ng problema sa KVL. Hindi nyo rin siya pwede iset as 0 kasi hindi naman siya open circuit. Naintindihan? So, importante na kunin muna yung circulating current. So, by applying KVL on this closed loop, so nag-assume ulit tayo ng current direction following the conventional flow. Nakuha. So, yun yung current direction natin. Then next is, we have the formula. So, E sub A minus E sub B divided by R sub 1 plus RB plus R2 plus RB. So, hindi natin iisa-isahin ha. Kasi same procedure na yan before. Then, sorry. So, this is circulating current. We still have the same 2 ampere. Nakuha. Okay, by applying KVL or Kirchhoff's voltage law. In this case, on this loop, although open yung ating circuit connection. Tama? Di ba open circuit to? Pero in calculating the KVL, we need to consider the battery. Yung source niya. Nakuha? So, initially, okay, start tayo rito. Positive, set tayo positive, negative. We have VTH. So, yung loop natin. And get the equivalent negative. I. So, in this branch, we have a series branch. So, connected yung R2 and internal resistance RB. So, R2 plus RB. And getting the equivalent voltage. E sub B. Negative. E sub B. Okay, next step is to get the voltage at E sub C. Okay, take note. Meron tayong internal resistance connected at hindi naman connected. Actually, inside the battery yun, kaya internal resistance. Pero since we have a resistance, kailangan ba nating isama sa computation to? Kasi di ba? Or do we need to get the equivalent voltage drop dito sa internal resistance RC? kailangan ba natin kunin yung voltage drop dito sa internal resistance? Actually, hindi na. Kasi take note, walang current na dumadaloy dito. Bakit walang current? Kasi yung circuit connection niya is open. Naintindihan? Ulitin ko, ang current lang will flow at a closed circuit. Pero in this case, dahil open circuit siya, walang effect yung ating resistance. So kahit pa mayroong resistor na connect dito, wala rin siyang effect kasi walang current na dumadaloy. Naintindihan? Okay. So, kaya it is equivalent to equal to 0. The next step, substitute following values, then we will get a Thevenin's voltage of 15 volts. Naintindihan? Okay. So, doon naman tayo sa external loop. So, the external loop, same procedure lang. We have a positive VTH, positive I times R1 plus RA. Ito yung series connection na. Yung masala. Yan. Ito. Di ba talaga? Ito nga, ayun ang magsagot. Nawala pala. Okay. So, ito yan. Next is to get the negative E sub A. Okay, again, we have the positive E sub C equal to 0. So, we will get the same Thevenin's voltage. Naintindihan? Okay, next is to solve for the looking back resistance. In Thevenin's voltage, sometimes ma-encounter nyo lang siya as the open circuit voltage. Naintindihan? So, open circuit voltage, then solving for the looking back resistance. Okay, looking back resistance, madali lang naman. So, pwede nyo naman masundan to. We have an equivalent of 1.5 ohm. Then considering the Thevenin's equivalent circuit, so we have the terminal voltage of Thevenin's voltage of 15 volts, Thevenin's resistance of 1.5 ohm, and the load resistance of 2 ohm. So to calculate the IL, like KVL, then we will get 4.29 ampere. Then to get the equivalent power, 3 power by hinanap. I-apply nyo na lang yung power formula. Walang sagot. Current lang. Kala ko power. So, kung power ang hinahanap, so you will apply I squared R. Intindihan? Okay. So, sige. Ihabol ko tong Norton's Theorem. Kasi, actually, same lang siya ng may effect or they have the same parameter na ginamit. Okay, in Norton's Theorem naman, we have a two-port network, di ba? So we are going to convert the two-port network or yung given circuit into its equivalent Norton's equivalent circuit. So in Norton's equivalent circuit, mapapansin nyo na we have a current source and two parallel resistances, wherein the source is called the short circuit current. Intindihan? Ito. For the short circuit current, and then we have the Norton's resistance, which is also known as or called as the looking back resistance. Same lang to. So, doon sila nagkapareho. Looking back resistance. And then, we have a parallel connected load resistance. Okay, for this type of circuit, we have the current source and two parallel resistances. So, sa tingin nyo, ano yung formula na pwede natin gamitin to find the load current? So, to find the load current, we are going to apply the current divider principle. Naintindihan? So, yung current divider principle natin, ito na yung simplified circuit, formula. Naintindihan? We will just apply the current divider principle to the Norton's theorem to find the load current. Okay, by the example. So, yung example natin, pareho lang ba ito nung ako? Hindi ko lang sure. Pero yung circuit kasi almost the same. Okay, determine the load current at 2 ohm resistor using Norton's theorem. So, ano ba yung kailangan natin sa Norton's theorem? So, in Norton's equivalent circuit, we need to find the short circuit current and the Norton's resistance or the looking back resistance. In this case, for Norton's theorem, the load RL will be shorted instead of isolating or disconnecting the RL to the circuit. Naintindihan? So instead of disconnecting the RL, we are going to short the connection for RL. So ito na yung mangyayari. One method to determine the short circuit current is to make the terminals AB to be shorted as shown. So once na ma-short natin yung connection for RL or load resistance, next step is to solve for the short circuit current. So how to solve short circuit current? So in short circuit current, actually we have three sources, diba? So meaning we cannot compute for the short circuit current using simple series parallel analysis. So we can use other method in this case. So applicable lang to in this method yung Norton's theorem. Same with the Thevenin's to find the VTH. Pero actually sa Thevenin's theorem kasi ang kailangan nating i-compute is yung current flowing on the branches. So in this case, still, yung short circuit current yung hinahanap natin. So paano natin compute ito? We can use mesh analysis. Naintindihan? So in mesh analysis, we can compute the current flowing on this branch. Kung saan connected yung ating load RL. Nakuha? Pero initially it is shorted. Okay. We can use mesh analysis to compute for the short circuit current. So actually, ito na. Nag-set na ako ng solution for mesh. So hindi na natin iisa-isahin kasi tapos na natin ito. So, naisulat ko naman yung mga solution. Intindihan? So, we will apply KVL on the first mesh and on the second mesh. Then, you can use your calculator to solve for the external branch current, short circuit, or the equivalent short circuit current kasi depende sa position. Pwede kasi yung short circuit or yung load resistance natin is connected at the inside the circuit. Pero in this case kasi nasa external branch na connected. So, mas madaling i-compute yung short circuit current. So, we have the equation applying KVL at the first mesh. So, we have the first equation, KVL at the second loop. Then, use calculator. So, yung branch current I2 natin, ito. Yung mesh current I2 is the same with the external branch current wherein the load RL is located. O yung short circuit current na hinahanap natin is at this branch. So, it is equivalent to 10 ampere. So, next, to get the looking back resistance, same procedure. Kunin natin yung equivalent resistance. So, neglecting the effect of the independent sources. And then, at terminal AB, kung saan connected yung load RL, so will be isolated. I-open natin yung circuit para mas madaling mag-compute for Norton's resistance or the looking back resistance. So, we have an equivalent of 1.5 ohm. The next step is to consider the Norton's equivalent circuit. So, in this case, we will just connect the current source or the short circuit current which is computed as 2 ampere to the parallel connection of the Norton's resistance or the looking back resistance. Ito yung computed value natin ng looking back resistance, and then connect natin in parallel to yung load RL sa ating Norton's equivalent circuit, and then solve for the load current. So load current can be computed again using current divider principle. So hindi natin kailangan tandaan or kabisaduhin yung formula. So alamin niyo lang yung pinanggalingan. Nakuha? So ito yung ating magsisilbing formula. So derive from ano tawag dito? Current divider principle. So yun lang. Okay? Wait lang. Another method. Actually, ito medyo hindi ko advisable to. Hindi advisable na gamitin ito sa solution. Pero ito kasi yung another way. Pero siguro hindi ko na muna. Hindi na natin dadaan. Kasi kailangan kong makuha is ito. When is a, when, if the given problem is looking for the Norton's theorem, so i-apply nyo itong formula natin or yung process. So, huwag kayong gumamit ng shortcut method. Yung shortcut method is can be used for checking lang. Naintindihan? So, you need to study the process of Thevenin's and Norton's theorem. Okay na? Sige. Actually, natapos na natin itong lecture natin. So, magbibigay na lang ako ng mga activities. Naintindihan? Then, next week, pwede na tayo mag-set ng quiz sa Thursday. So, sa Thursday, ang quiz natin, ang coverage is mesh, nodal, and superposition theorem. So, sa mesh and nodal, wait lang. You can use calculator. Naintindihan? So, magbibigay ako ng problem set. Okay na, sige. 9:05 na pala. Okay, sige. Lipat na lang tayo ng room. Gagawa ko ng bagong meeting room for mechanics. Okay, sige. Pero pwede naman kayong mag-agahan habang nag-lecture tayo. Hello. Kasi hintayin nyo na lang yung tawag dito, bagong meeting room for mechanics.
Thank you, sir.